Literal equations. So a literal equation or a formula is basically an equation that involves more than one pronumeral. Sometimes I think a literal equation might often involve no numbers at all, but essentially what we're talking about is a problem here that has more than one unknown involved with it. So we're talking about just algebraic manipulation really, and being able to rearrange these equations to make a particular pronumeral the subject. And really, if your understanding of what you're doing when you're solving regular equations is good enough, solving literal equations is no more difficult. It's about thinking about what's happening to the unknown and how do I undo those things. So when we're dealing with literal equations or formulae, we refer to the subject of the equation as being the variable on the left-hand side of the equation on its own. So for example, in the formula or the literal equation, a is equal to pi r squared, we would say that a is the subject of this formula. In the formula a is equal to L times W, we would say that a is written in terms of L and W. So a is the subject and it is described in terms of L and W. In the formula L equals A divided by W, we would say that L is written in terms of A and W. So in this case, L is the subject and it's described in terms of A and W. Understanding this phrase in terms of is quite important. You're quite often asked to express y in terms of x, or express the volume in terms of x, or express whatever in terms of something. It's important that you understand what that means. So a formula can be transposed or rearranged to make another variable the subject, which is what we really want to have a look at here. So let's consider this formula or this literal equation. So we've got 1, 2, 3, 4 variables here. And at the moment, v squared is the subject of this formula. So we want to first of all, in part A, rearrange or transpose this formula to make A the subject. So this is what I'm trying to isolate now. I want to get the A on its own in this equation. So you need to break it down. You need to be able to think about what is happening to A in this equation or this formula, and then undo those things. So we can see A, there's a whole lot of things going on that right hand side that we need to get rid of. So I like to sort of write it out. The first thing that's happening to A is it's been multiplied by 2 and it's also being multiplied by x. So A has been multiplied by 2x. Then you've had u squared added to that. So we need to undo these things. So the first thing we're going to need to do, so I'm just going to write out my formula here, v squared is equal to u squared plus 2ax. So the first thing we need to undo is this, adding u squared. So the opposite of adding u squared is to subtract u squared. So we want to subtract u squared from both sides of our equation. So we're going to get v squared minus u squared on the left-hand side, and subtracting u squared from the right-hand side will get rid of it. And so we've undone that. Now we need to think about this and undoing this. So we're trying to isolate A. At the moment it's being multiplied by 2x. So we need to do the opposite of multiplying by 2x, which is to divide both sides by 2x. So we're going to have dividing by 2x on the left-hand side, and dividing by 2x on the right-hand side will simply leave A. Again, the convention, if you're asked to make A the subject, you really should write it on the left-hand side. So A is equal to v squared minus u squared all over 2x. Okay, part B, we want to take this same formula. I'm going to write it out again. So v squared is equal to u squared plus 2ax. And this time, we want to isolate u. So we want to make u the subject. So we just need to think about what's happening to u. So we started with the u. U's on the right-hand side. So what else is happening on the right-hand side? So it's been squared. And then we've added 2ax. So we want to undo those things to get back to u, to isolate u on its own. So the opposite of adding 2ax is to subtract 2ax. So I'm going to subtract 2ax from both sides. So we're going to have v squared minus 2ax on the left-hand side, and subtracting 2ax from the right-hand side will simply make it disappear, which was the whole purpose of choosing to do that. Now we wish to take the square root of both sides of this equation. We've undone the 2ax, so now we want to undo this. The opposite of squaring both sides is to square root both sides. So I want to take the square root of both sides of this equation. Now we need to be careful whenever we take a square root, we could have positive or negative. So positive or negative square root of v squared minus 2ax equals u. So making u the subject again, so u is positive or negative square root of v squared minus 2ax. Depending on your problem, there might be reasons why u can't be a negative value, and so you might be able to say u equals positive square root of v squared minus 2ax since u has to be greater than 0, or whatever the reason might be in your problem. But in general, taking a square root always will result in a positive or a negative result, and you need to acknowledge both. Okay, example 2. Rearrange k equals 3l plus 4m to make m the subject. Okay, so we've got k equals 3l plus 4m. So we want to isolate m. We think about what's happening to m. Well, the first thing happening to it is it's being multiplied by 4. Then we've added 3l to it. So the first thing we're going to want to undo is this adding 3l, and we're going to do that by subtracting 3l from both sides. So k minus 3l on the left and just 4m on the right. Next we want to undo this multiplying by 4, so we're going to divide both sides by 4. So k minus 3l divided by 4 is equal to m. Okay, so just write m as the subject, so on the left hand side, k minus 3l divided by 4. Example 3. Rearrange t is equal to a divided by 4r squared to make r the subject. Now, before we can actually think about what's happening to r here and what we might need to undo it, the first thing I want to deal with is the fact that it's in the denominator of a fraction. So I want to get rid of it. I want to get it out of there first. And again, you can think about this in a couple of different ways. This is a fairly simple equation, but really, in any time we're dealing with fractions, what we're doing is we're writing both sides with the same denominator, and then we're multiplying through by that denominator to cancel it out. So if I think about that same logic here, my common denominator is 4r squared, so I want to write both sides of this equation over 4r squared. On the left-hand side, I've multiplied the denominator by 4r squared, so I need to do the same to the numerator. On the right-hand side, I haven't done anything to the denominator, so I don't need to do anything to the numerator. Now multiplying through by that common denominator, so multiplying both sides by 4r squared, I get 4r squared t is equal to a. Now in this case, that was fairly easy to go straight from here to here, just multiplying both sides by 4r squared. That's really what you're doing. But that's what's going on inside there. That's why that works. You've written both sides with that common denominator and multiplied through by that common denominator. Okay, so now we've got rid of the fraction, and more importantly, we've got our unknown out of the denominator of a fraction. Now we can break down what's happening to r. Okay, so r's on the left-hand side. What's going on that left-hand side? If we start with r, the first thing happening to r is that it's being squared. So this is really important that you know about your order of operations, BODMAS or BIDMAS. Okay? The O, and the reason lots of people learn BIDMAS these days, isn't of, it stands for order, to the order of, it's powers. Okay? So this is, your powers come second only to any brackets. So that squared is happening before the multiplying by 4, before the multiplying by t. Okay, multiplication happens down here in the order of operations after the powers. So r is being squared first, then it's being multiplied by 4 and also by t. So we want to undo these things. I want to divide both sides by 4t. So r squared will be a divided by 4t. And then I want to take the square root of both sides, remembering that I could have positive or negative square root. And so r is the subject. In example 4, I wish to rearrange to make h the subject. So we're thinking about h, so we've got p is equal to 2 pi square root of h plus k over g. Okay, so it's not in the denominator of a fraction. I can think about immediately in this particular expression on the right-hand side, what is happening to h. So we're starting with h. The first thing happening there is that we add k to h. Then we've divided all of that by g. Then we've taken all of that and taken the square root. And then we've taken all of that and multiplied by 2 pi. So there's lots of steps here, but it's fairly routine. So the first thing we need to get rid of is that multiplying by 2 pi. The opposite of multiplying by 2 pi is to divide both sides by 2 pi. So p divided by 2 pi is equal to square root of h plus k over g. So we've undone that. Now we need to undo that square root. Opposite of the square root is to square, so we're going to square both sides and get p over 2 pi squared. When you square the square root, it just disappears. They cancel each other out, so h plus k over g. So now we've undone that. Now we need to do the opposite of dividing by g, so we want to multiply both sides by g. So we're going to get g times p over 2 pi squared equals h plus k. And so we've dealt with that. And so the last thing we need to do with this, deal with this at plus k. So we want to subtract k from both sides. So g times p over 2 pi squared minus k is equal to h. So you want to write h as the subject. You might also find that that term with the g and the p is expanded out a bit, but this is perfectly correct, what we've got written here. So you can just write it as g equals p over 2 pi all squared minus k. You might instead write it as gp squared over 4 pi squared minus k. Both are correct. Okay, in this last example, example 5, we wish to rearrange ut equals 2s minus vt to make t the subject. Now the first thing that we notice that's problematic here is that we don't have just one t to isolate. Okay, so you haven't made t the subject if you just divide by u. T equals 2s minus vt over u, because it's still got t in it. So you've got t in terms of t, you haven't isolated t and made it the subject of the equation. So our first problem is getting those t's together. So there's only one t in my equation. So I'm going to start at least by getting them on the same side of the equation. So I'm going to add vt to both sides. So ut plus vt is equal to 2s. And now, if we had numbers here, so just as an aside over here, if this was 2t plus 3t equals 2s, then we could collect those together, because 2t plus 3t is 5t. And what I want you to be clear about is that 2t plus 3t is 5t because t is a common factor. Because they're like terms, they have a common factor of t. So if you take out that common factor of t, t is equal to t multiplied by 2 plus 3, and so that's why we get 5t. And so we want to think about that same thing in this literal equation here where we don't have numbers, and that's not as obvious. So what we can recognise here is that t is a common factor, so let's take it out. So we've got t multiplied by u plus v equals 2s. Now we've got a very simple situation. We're trying to isolate t. T is being multiplied by this bracket, u plus v. So the opposite of multiplying by u plus v is to divide by u plus v. So we're going to divide both sides of this equation by u plus v. And we're done. We've made t the subject. This is a fairly common process. If you've got more than one instance of your unknown in a literal equation, get the terms involving the unknown on one side, factor out that unknown, and then go from there.